All right. Hello, zoology people. Back finally here to continue onwards with our course. I hope you have been doing well. I know there's a lot of mess out there. I hope you've been staying safe, doing well, keeping up with everything. So I know we've completed the fish. We've completed our bony fish, our Osteichthyes category. Now we continue with our evolutionary process. We get into the discussion of sort of mobility. We go from the finned organisms to what we call the tetrapods. So we start to focus on this last sort of branch on this tree here. Here's our history, our chondrichthyes, the sharks. We look at our bony fish, our different lungfish, coelacanths. We didn't really discuss these too much, but they're the transitional fossils that we see from the fish, the proper fish, into then our tetrapod group. So there's our Sarcopterygians, the coelacanths. We see all these little branches, these evolutionary sort of experiments trying to invade now a terrestrial world. So everything we've talked about so far has been in the aquatic environment. But understand there's this land, there's all the continents now without predators, with a bunch of insect life, prey items. So any organism that could sort of move onto that new platform, onto land, it would open up a whole bunch of new habitats and a lot of opportunity for evolution and selection, that kind of stuff. So we start to see these branches. The amniotes are going to be another big category that we cover later with reptiles, birds, and mammals. But we're going to focus on this trajectory here. We call the lysamphibians, which are what we consider modern day amphibians, right? Our frogs, salamanders, caecilians. So this is the discussion that we'll have for this next section here. So again, just hypothetical type of bone modifications. So if you're going to be moving from an aquatic realm where there's buoyancy, there's sort of something that takes pressure off your joints and bones, less of an effect of gravity. And now you move on to land, you face two big strategies, two big challenges. One, not to dry out because it's much drier on land, obviously, than in water. And two, being able to support a heavier force of gravity, right? More mass. We don't have the buoyancy of water surrounding us. So these are some of the skeletal transitions that we start to see, right? Pelvic girdles, sort of the forearm supporting more weight. You see a more stout modification on the bone structure. So again, this is that transitional phase that we're going to kind of get into now. So again, we have the same bone structure, or the same bones, I should say, just modified for their particular use, their function on land. So we see a more elongation, more mass to the bones to be able to support more weight. So this is going from that aquatic environment then to the terrestrial environment. And again, some of these lobed fin fish, we start to see then that it's not, that sort of difficult to see over the course of millions of years of evolution how little mutation, little selective forces could have an impact on those bones there. So much stouter sort of pelvic girdles and also scapular girdles as well here. Ichthyostega is a well-known fossil sort of transitional organism, and we start to see that more stout sort of thoracic chamber. We start to see more bone structure to support mass, heavier skull, and again legs, and it's just a transition from the aquatic world to the terrestrial world. So same kind of discussion there. Ichthyostega again, showing the pelvis and seeing modifications on that organism. So again, where are we at here, right? There's that organism we just saw, sort of that extinct form. And then we start to see this branch here. So our discussion for the next chapter here is going to focus on what we call Anura, Caudata, and Gymnophiona. So they do have a common ancestor here, but they are going to be distinct forms, these two more close related than this one. So these are the ones we're going to be focusing on. A lot of these then are extinct taxa, and the amniotes, which we're going to get into again in the next chapters ahead. Right? So for the final. So an artist rendition of what the Devonian period must have looked like. These transitional organisms that are experimenting now with life on land, but still have heavy ties to the aquatic world. So, and for this little section, this is going to be the last slide, but I am very eager and very excited. I consider myself a herpetologist. A lot of people don't know what that means. Oh, you study herpes? Like, no, I don't study herpes. Herpetology is the study of reptiles and amphibians. I focus more heavily on reptiles, but amphibians are also part of my repertoire here. So herpes in the Greek language refers to like something creepy crawly. And a lot of people think, ooh, amphibians or reptiles are creepy crawly creatures, right? So reptiles over here are a different branch. They're going to be is a fairly diverse group of organisms. The branch we're going to focus on right here is our frogs, salamanders, and then our caecilians. So different groups that we're going to look at, and I'm eager. I'm excited. This is part of the semester that I love here, right? So let me stop this here, and we'll get into our next discussion right away.